Good day everyone. By the way, I am Iris Argayola, and for today's video, I'm going to present to you the continuation of our discussion, which is Chapter 9, Analysis of Data.
Chapter 9, Analysis of Data. When we hear the word analysis of data, it talks about that the
data analysis is the most crucial part of any research. Data analysis summarizes collected data. It involves the interpretation of data gathered through the use of analytical and logical reasoning to determine patterns, relationships, or trends.
Statistical analysis, or statistics,
Is concerned with the development and application of methods and techniques for organizing and analyzing data, usually quantitative, so that the reliability of conclusions based on the data may be evaluated objectively in terms of probability.
There are two major areas or types of statistics: theoretical and applied. Role of statistics. Generally speaking, statistical analysis may be used to accomplish four basic purposes.
1. Statistics may indicate the central point around which a mass of data revolves. 2. They may show how broad or diverse the spread can be for a mass of data. 3. Statistics may reveal how closely or distantly certain features within the mass of data are related, as well as whether a relationship even exists. 4. They may indicate the degree to which the facts might be occurred by mere chance, or whether there is a probability of their having been influenced by some factor other than pure chance. The last function is accomplished with statistical tests of the hypothesis.
In short, the basic purpose of statistical analysis is to summarize observations or data in such a manner that they provide answers to the hypothesis or research questions. Cautions in using statistics. In addition to keeping in mind that the statistical analysis cannot do the interpretation, the researcher should be aware of other concerns in using statistics. The establishment of categories. In establishing categories, four basic rules or guidelines should be followed.
1. The set of categories or values. 2. Each set of categories should be exhaustive. 3. The categories within each set should be mutually exclusive. 4. Last, but not least, the development of categories should be based on a sound knowledge of the subject matter and an anticipation of likely responses.
Coding the data. In actually coding the data, researchers traditionally have transcribed the observations or scores for each individual or case from the data collection instrument to coding or transfer sheets. Analyzing the data. Descriptive statistics. Once the data are ready to be analyzed, the researcher can choose to utilize a descriptive statistics, inferential statistics, or both.
6 basic functions that they can perform. 1. At the most basic level, the statistical analysis can indicate how many persons, objects, scores, or whatever achieved each value for every variable that was measured. 2. When it may be difficult to grasp the overall meaning of frequency distribution tables, pictorial representations can be used to portray a variety of characteristics of the cases or individuals with respect to the variable or variables measured. 3. Descriptive statistics are capable of characterizing what is typical in a group of cases. 4. Descriptive statistics can indicate how widely cases in a group vary. 5. Descriptive statistics can measure the relationship between or among different variables in the data. The 6th basic function that descriptive statistics can perform is to describe the difference between two or more groups of individuals.
Analyzing the data. Inferential statistics. Using inferential statistics as first described, one could measure the loss rate for a sample of books, and then predict the loss rate for the entire population or collection based on the sample statistic. In short, inferential statistics help one to make inferences and judgments about what exists on the basis of only partial evidence. Parametric statistics.
Parametric tests are relatively powerful, or likely to detect a difference between groups if a difference really exists. In other words, the power of a test is directly related to its ability to eliminate false null hypotheses.
Some examples of frequently used parametric tests include the following. 1. Z-test. This test, using standard scores, tests the difference between a group's results and the results that would be expected due to chance alone. 2. Students t-test. A test that can be used in place of the z-test where there is still only one group, but where, in contrast to the z-test, the standard deviation of the population is not known. 3. Difference of means. A commonly used statistical test which utilizes the t-statistic, and which determines if the statistical difference between the mean scores of two groups is significant. 4. Analysis of variance. A statistical test, which represents an extension of the difference of means test. 5. Post hoc tests. These test the statistical significance of differences between group means that have an overall difference calculated after an ANOVA or a regression analysis RA has been done. 6. Reliability coefficient. A statistic that indicates the reliability of a measurement, that is, a test, scale, Pearson's etc.
product moment correlation coefficient This test generally is referred to as simply the correlation coefficient. It measures the degree of linear association between two variables. 8. Regression. A type of analysis that, as is the case for correlation, can be used for descriptive and inferential purposes. Non-parametric statistics.
In contrast to parametric statistics, non-parametric statistics are considered to be distribution-free. That is, they do not require the assumption of a normal population and, therefore, are often used with smaller samples.
5 common examples of non-parametric are as follows. 1. Chi-square test X2. This test is useful for determining if a statistical Isofin relationship exists between two categorical variables. 2. Mann-Whitney U-test. This is one non-parametric equivalent of the difference of means test, and is used to test for a significant difference between two groups. 3. Wilcoxon sign test. This test can be used instead of the Mann-Whitney when the data are not symmetrical. 4. Spearman rank order correlation, or Spearman's. This is a non-parametric correlation coefficient that can be calculated for ranked or ordinal level data. 5. Kruskal-Wallis test. A non-parametric alternative to analysis of variance. It is appropriate when one has a number of independent random samples and an ordinal scale level of measurement. Cautions in testing the hypothesis.
In using statistics to test hypotheses, one must always keep in mind that statistical inferences are based on probability, and one can never rely on statistical evidence alone for a judgment of whether a hypothesis is true. Such a decision must be based on the presuppositions or conceptual basis of the research as well.
Statistical analysis software.
Today, quantitative analysis is almost always done by computer programs such as SPSS and Microcase. In using computers for statistical analysis, one should be careful that the ease of doing so does not waste the researcher's time.
Analysis of non-quantified data. It is worth noting briefly at this point that not all research data are susceptible to quantification, and such data do not lend themselves to statistical analysis. Reflection. Thank you.